All right, I think we're live. Let me see here. All right. I don't know if I'm live right now. I'm going to check my phone. Check, check. I guess I am live. Well, that's pretty cool. I guess I am live. Well, that's pretty cool. All right. Well, if anyone's out there, I don't see. Let's see, just one watching. That's me. All right. Well, let's get started. Okay, so what I'm gonna do is actually program a part. It's a plate. It's a 1 inch thick G10, which is fiberglass. So if you can see this, it's just a basic part. Just so you guys can see it. Let's see if I can change the color of this here. Let's add a material to this. It is G10, which is fiberglass. I don't see it there. Let's see material. Let's see. Green. Let's just call it green. Hey, why not? Green, polished. No, olive green. Yeah, that's about. Yeah, olive green. That's about the right color. All right, cool. Let's do that. Oh. What's going on here? Boom. Okay. Cool. Now we got an olive green part here. Let me actually change the view and make it some edges here. So this is an inch thick part. It's about 13. Go to the top view here. It's about 13 inches tall by 9 inches wide. It's got 96 holes in it. It's got a counter bore in there. Got through holes right here, 325. Or sorry, 3125, 5/16 basically. So this part is going to go to a customer, and I am going to show you how I program it. This is a quick and dirty thing. So what I'm gonna do, I'm in Autodesk Inventor, by the way, 2023. I know it's 2025 right now, but who cares? But anyway, so this is a fiberglass part, and I have a Langmuir Systems MR-1 CNC machine, which is, I guess it's a hobbyist machine, but it does a really good job. I mean, it's got some pretty good precision. So anyway, I'm going to program this. I'm going to show you guys how I do it. So the first thing I'm going to do is go up here and hit cam, and I'm going to set it up. And so what it wants me to do is actually say, okay, I see your part, but like, do you want me to add extra material in the end? Like how much you're going to take off, whatever. So it doesn't matter what I do. It doesn't matter the stock size in this, because I know on the machine, I'm actually going to be strapping down a bigger piece, and I'm just going to manually strap it down for this part at least. So I'm going to select the machine and just a basic 3-axis mill here. Next, it says operation type. Obviously, it's mill because the Langmuir system is a gantry mill. So the stock point is going to be right here, but I'm going to click this point right here, and it's going to move it. But you can tell there's some extra material on the outsides of it. I don't want that, because I want to actually reference my part based on the actual part. So I'm going to go to stock, which is up here, and it automatically adds 40,000. So I'm going to click this down with my wheel, click this down with my mouse wheel. And so if you could tell, it actually took off this side extra, and which is exactly what we want. But now we got to fix, you see the Z right here? That's not correct. Z actually has to go this way instead of straight back towards me. So let's go back to setup. And we already picked the stock point, pick the model orientation. This is what direction we're going to pick things. I'm going to start with Z and X axis planes. And it's, since the Z is highlighted, I'm going to pick something that goes up and down on my Z, which is a part of my part here. And you could tell, boom. Now my Z is correct, my Y is correct, my X is correct, but it's in the top left corner, and I do all my machining, roughly 99% of it, in the bottom left corner. So what I'm going to do is actually pick a point, stock point, and I'm going to re-click it down here. So now everything's lined up. So my X, Y, Z is good. The top of the part is good. And the directions are good. Okay, so I'm going to click OK. All right, cool. So now I set that up. I'm going to right click on setup. I'm going to say new operation. And what I want to do is actually, the first thing I want to do is cut out these counter bores. Let me take that back. The first thing I'm going to do is actually drill these. I want to drill all 96 holes. So I'm going to hit drill. Now it's asking me what kind of tool I want. G10 Fiberglass, for those who don't know, is actually a composite. I am not going to use flood. I'm going to disable that. Okay. The tool, I'm going to use a 0.3125 5/16. So tools, any type. I'm going to click down to any drill. Now I'm going to scroll down to, and this mixes millimeters and standard, right? So I am going to, give me a second here. Since this is live, I'm actually monitoring this. Oh, two watching, cool. All right, so I am going to actually go down to 0.3125. I'm gonna take the scroll down here. And if you are leaving comments and stuff, or if you can't, I'm sorry, I can't see them right now. This is kind of like my first stream, so just bear with me. So I'm gonna go down to a 3125. Where is it at? I'm at 332. Let's go back up here. 5/16 drill. Okay, so now I clicked on, there's a few 5/16 drills here, right? So I'm going to scroll to the right, and on the very right side it says aluminum, brass, bronze, copper, carbon steel, I believe that is. Let me scroll this out. Actually, there it goes. Whatever. Yeah, this is a carbon steel. This is carbon steel. Plastics. So I'm going to click on the plastics one right here, and the spindle speed says 2440. Cutting feed rate is 19. So typically what this is talking about is actually material. It's plastics that can melt. Okay, composites don't melt, they burn. So we're going to adjust the speed and feed in the other menu over here. But I needed to pick this 5/16 drill, which is a 0.3125. So I'm going to hit OK. So that drill is selected. Now my gantry mill, the Langmuir Systems MR-1, has a top speed of 8,000 RPM for the spindle. Okay. Plunge rate, I'm just going to put about 10. Let's back it off to 8, because I can change these on the machine side too. So retract, the maximum retract is 40 inches per minute. I know, don't laugh at me, it's pretty slow. So I'm going to do 8, and I'm going to keep that in mind, because when I do peck drilling, which is like it goes down, it comes up a little bit, it goes down a little bit further, comes up a little bit, right? So that's called peck drilling. When I do that, I'm going to probably peck drill maybe 25 thousandths at most. So if I do a plunge rate of 8, that should be fine. Okay. And more than likely will not need a spot drill for these because the tolerances are relatively loose. If you have higher tolerances, you're going to want a spot drill, especially if you have harder material, because you're going to get some wobble in the drill. But I'm going to actually shorten my drill when I put it on my machine so it doesn't have so much deflection and basically tool bend. So, all right, flood, I'm going to turn that off again, disable that. All right, so I got 8,000 RPM, tells you the surface feed, tells you the plunge rate, feed per revelation, and retract feed. So I'm going to go to geometry. So now this is where it says, okay, go ahead, John, pick the holes that you want to pick. And so if I go over here, I'm just going to click on, when I highlight over this in Inventor, it shows this like bright green color because it's green, but I'm going to click on that, and you could tell this little yellow line right here. This is my first tool path. Okay. So it's going to come down here. Let me zoom in a little bit. It's going to start, the tool's going to wrap it to this point, and it's going to come down here to a certain feed rate. Then it's going to stop at this top green piece right here. Okay. And then it's going to go down all the way to the bottom of my hole. Okay. If you can see that, right. And it doesn't poke through. We're going to change that in a second. Okay. So, but first right now, what we got to do is just pick all of the holes that we want to drill. So we're going to drill that one, this one, I'm just left clicking here. And by the way, I'm using the Space Mouse. I don't know if you guys ever used it. I love this thing. You can like flip the part around, you can move it around, you can rotate the part, zoom in, zoom out. This thing is great. I worked at the last company I worked at, they had these, and I had no idea how to use these things, but I love this mouse. It's a Space Mouse. I'm not sure who it's by, but I think it's 3D Connections or something like that, but they are worth the price. I think they're like $300 right now. So I'm going to just click them in a row. Just imagine that I'm going to come down this row with my drill, and I'm just going to drill away at these holes. So there's actually 96 of them. And you can tell that, see this yellow line right here? This is kind of like the tool path, and the program is trying to figure out, okay, which one should I do first, whatever. We're going to fix that later, okay? So first, right now, we're just going to pick all of the holes that we want to drill out. Then we'll come back and do the counter bores after that. Boom, boom. I know this is kind of tedious, but so if you've ever programmed parts before, and there's tons of features that you got to do, it can get tedious and monotonous. And in certain ways, there are quicker ways to do this. You know, you put it in the window and you highlight everything, and it does everything in that one fell swoop. But since I've got counter bores and other features, I don't want to pick those and accidentally crash my tool into something. So let's, I'm just going to pick these individually, and let me see how many I got. Oh, I got 3 rows left. Perfect. All right, I'll go a little bit quicker. I don't want this to be like a 4-day long video either, so I'm gonna pick that. Almost done, guys. Let me see here. Here. Boom, boom, boom. And again, this is my first stream. I hope my audio and everything is working right. So, all right. So if you could tell, I've got all of the holes picked for our drill cycle. All right, so over here it says, okay, you want to pick the faces, pick the, you know, the geometry you want to use. I'm gonna optimize the order, so by selected. So how I selected it was this top one first, and it went all the way across this way. It's coming down, and then it's gonna come back all the way this way. It's gonna come down all the way. So I put it in order how I picked it. So that's how you do that. Order selected. Okay. All right, cool. So now we've picked our geometry we want to do. Now we're going to choose our heights, okay? So you got retract height, stock height, feed height, top height, bottom height, okay? So we can, you know, start anywhere we want to. There's a drop-down menu here for bottom height. So I'm going to go to selection, and I'm just going to pick this little line at the bottom of my part. And that's not the exact bottom I want to go. I'm going to click on front. because you can tell that the drill is only gonna, the tip of it is only gonna go to the bottom. It's not gonna go all the way through, but I need it to go all the way through. All right, so let's go negative because we got to drop it down 0.050. Let's see what that looks like. Oops, let me go front again. Sorry, guys. Click the wrong one. Fat fingered that one. All right, you could tell even at 50 thousandths, it didn't go all the way through. So let's go a little bit further. So negative 0.125. Let's go an eighth below it. So you can tell it's gone actually all the way through. Why does I keep doing that? All right, so the tool has gone all the way through, okay? Just to be safe, let's go negative 0.150. Bam, okay, cool. That looks good. So you can tell this is the front view. The tool has gone all the way through. Perfect. Or you can click on this little thing that says drill tip through the bottom. I like a little bit more control. I know that it's going to go 150 thousandths below all of those. So, all right, so now the top height, which is this blue color. Let's see here, click top height. Let's go ahead and hit selection again. And you can see when I hit selection, it says top is at 0, right? So, which is where I want it. That's great. But these turned red now, which means that there's some issue with the previous heights. So the feed height might need to go a little higher. So I'm going to scroll up a little bit. Let's go the stock top height. Let's move that up. And you can see that these things are moving when I scroll up, right? Stock top height, I'm going to select this too, which is right there. Perfect. And that didn't like that either. Maybe it needs a safe one. Let's go 0.6. All right. So retract height is going to be actually, I want that to be, let's go 0.5. Top of the height is going to be 0. And if I highlight over this, it'll give me a menu, top of the height, and it'll show you like top height. It's going to be like where your feed height is, right? So it's going to wrap it down to this point, to a certain point above your material before it starts cutting. And it's saying, hey, your top height for feed it's the same as your top height for your part. So you're going to crash into your material. So you need to bring this up just a little bit. Okay. And if I highlight of it, it says failed to evaluate expression. Feed height offset is applied and is relative to the feed height selection in the above drop down list. Okay, cool. Great. So let's put this the top height. Okay. I changed my top height of my stock to top height instead of selection. Okay. Because it knows where the top of your stock is from what we picked in the previous one. So retract height, let's just keep it on feed height. That works. Now, as long as these are all not red, you are good to go. And we have a little preview here of where the part is going to go. And actually, let's go to the next. I'm going to click OK. I'm going to right click on my drill and I'm going to hit simulate. Okay. So this is my tool up here. Okay. It's got the tool holder. It's pretty cool. And when I click play, it's going to show me what's going to happen. And let me put this view in actual so you can see through it. Okay. So now you can see kind of like a wire, right? So let me go to the front view and it might be better to, might be easier to see that. So I'm going to click play. It's going to drill down, drill down, drill down. You can't really see that either. Let me go wireframe. Let me back that up. Okay. And I'm going to slow this down right here. Click play. Now my drill is coming down. It's going to stop at a certain point. It's going to drill all the way through, go past my material, pull back up to the retract height, go to the next hole. It's going to drop down, go all the way down. So I don't want to drill this. I'm going to hit pause, actually close. I don't want to drill all the way through my material in one shot because you're going to get a collection of material in your cutter. I'm going to get a collection of material in my cutter, in the flutes of my drill, and you're going to start to either burn the inside of this hole, you're going to start to scratch the inside of this hole with the cutout material, which I don't want. I want a good surface finish on this. Or you're going to deflect the tool so much because it's trying to work for you, but you got to give it some, some patience here and just let it do its work. So let's go ahead and I'm going to right click on the operation I just did, left click on edit. So what I got to do next is in this cycle tab up here on the top. Right now it's default set at drill rapid in and out. Okay. If I highlight over it, it tells me all the different types of drilling cycles it'll do, right? So deep drilling, chip breaking, whatever. So what I'm going to do is actually, I like to do chip breaking. So it's going to break the chip at a certain depth and it's going to pull up, and then it's going to go a little bit further, then it's going to pull up. So what it does is it cuts a little material, pulls it out of the hole, goes deeper, pulls that out of the hole. So you don't have that issue of burning the inside diameter of your part here. So the pecking depth is going to be 78 thousandths. I want to drop that down to, let's go 25 thousandths just to be conservative, because again, I can change this later. This is just a quick and dirty lesson right now for you guys. Pecking depth reduction, I don't really use that. The minimum depth, okay? So it's got to go down 25 thousandths, then it's going to pull up. Accumulated depth, that means from the very top of this part, how far deep it cuts down to the material, right? So until it retracts, okay? Accumulated depth means that it's going to go down, in this case, 0.781 down, and then it's going to do a full retract, and then it's going to continue its cycle, right? So what I want to do is change this to 0.5. Oops. Let me try that again. Edit. Cycle. Chip breaking. Where'd it go? Oh, chip. Here it is. Sorry. All right. Chip breaking. So it's going down 1.25. This is going down 0.78. I want it to go a ½ inch and then fully retract, because this is a 1 inch piece of material. Chip breaking distance, that's how far it pulls up and then continues its drilling, right? So 6 thousandths, that's fine. I want to do a little bit further, 0.01. Again, I'm being conservative. This dwell period, which means it's going to drill down into the hole and it's going to stop. It's going to dwell there for a certain amount of time, right? And what that is it prevents a chip at the very bottom of your hole from messing things up, okay? So if you want to dwell, that means if I go 0.25, that means a quarter of a second. So if I go 1, that means it's going to dwell. It's going to go down and it's going to stop for 1 second, and then it's going to retract, and then it's going to keep drilling, right? Well, that's too long. That increases your cycle time, and with cycle time, it just gets longer and longer. So anyway, these are the settings I do. So if I do, I clicked OK. Now I'm going to go ahead and do simulate again. And you're going to see, let me change the visual style to hidden lines. You're going to see it go down, come a little bit, come back up, go down. So here we go. It's going to go down. It's like pecking. Then it's going to retract halfway through, all the way, just to pull all the chips out. And then it's going to go back down and finish the rest of the hole. Boom, doom, 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 doom. So it just pecks all the way down, and it's going to peck all the way up, or it's going to pull all the way up. So if you notice, it does it in 3 cycles, 3 steps, right? Which means that it's going to take a long time. So anyway, I need to change a little bit. So what I noticed was it goes all the way down, or I'm sorry, it goes halfway, pulls up, goes the other half and pulls up. And then it has a little bit further to go, like 125 thousandths that we set to go. That's the 3rd time it goes down. So I need to change the cycle to where I want it to go all the way down halfway, pull up, and then go all the way through again and pull up. I don't want those 3 things. So the total pecking distance, I'm going to change the accumulated depth. Let's go 0.5. Since we went, let's do 1 inch plus, we went another 150. So let's go 0.650. So 650 thousandths, and that should fix our issue here. So let me right click on simulate, and this should only peck down twice. 1, 2, and it's done. And it moves on to the next part, our next hole. Boom, 1, 2. Okay, cool. I like that. And that should be good for the drill cycle. All right, so let's go ahead and do the other part. Let's do the counterbores here, okay? So now we go back up to setup, right click, new operation, and we're going to do a 2D mill drilling cycle, okay? You got 3D mill, you got drilling, you got 2D mill, you got multi-axis, right? If you want, you know, like 4-axis or whatever. We're gonna do 2D, and we're gonna do a contour, okay? So we're gonna change the tool because we don't want to use the same drill we did. So I'm going to go to all tools, and what I'm using is a end mill that cuts carbon fiber, and it also cuts composites. It cuts G10 fiberglass, right? So go by type, and we're going to go to any mill, and it's going to be a 1/4 inch flat. So 1/4 inch flats right here. So you've got a selection of them based on the materials that you're using. Let me select over to the right side. All right, and you can have aluminum, brass, copper, all these things, right? So I'm just going to click on plastics again just to keep it consistent. All right, so now again, my machine only goes to 8,000 RPMs. It's a MR-1 Gantry Mill. So I'm going to put it up to max speed, okay? Take off the flood, don't need the flood. The tool is set as a 1/4 inch. All right, surface speed. Now, cutting feed rate. This is how fast it's going to cut through our material, okay? So I am going to change that. Let's change it to 10. Again, being conservative. And we could change this later. We change it on the machine if we have to. Okay. Feet per tooth, don't worry about it. Lead in, lead out. We're not going to have that, but I'm just going to leave the speeds the same there. Plunge. Let's do 5 so we're not crashing our tool too badly. If we're running like a 30,000 RPM spindle or something like that, that would be super slow. I mean, you could plunge it at maybe 20, 30, 40 inches per minute, but my machine only goes up to 8,000 RPM. So anyway, now we're going to select the contours. Okay, so we'll just select this one. And right when I selected it, this like red arrow came up. And as long as that red arrow is in the counterclock direction, because we're climb milling, right? And on the inside of the circle that we just selected, we're good. Okay, so I selected that one. Select this one. Just the top of the hole. Bear with me. And again, this is I'm using the space mouse, which gives you really good control. I love this mouse. Clicking that. Here. This over here. Select all these. And if you're watching this video later, you can just fast forward till I get to the last hole, because this is not the funnest thing. Boom, 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 boom. And again, I'm in Inventor Cam, which is Autodesk. It's kind of like the brother or sister to Fusion 360. And you could tell I missed a couple holes here. I'm going to click on those, and I'm going to show you if I'm going to show you how to, click that out. If I accidentally click something, like say I click this bottom hole here and it's like at the very bottom of the hole, I'm going to click it again, and I'm going to click this trash can icon. It takes it away, right? So you don't have to reselect them all. All right. And here. There are 96 holes, guys. I'm sorry. But, you know, repetition actually makes you smarter. Or it should. Okay, there. And the more I click, the slower my computer is slowing down because it's like thinking. Like, duh. All right, and clicked it. There it goes. And there are other faster ways to select this. I'm just showing you one way to do it. Boom, boom. This, I'm just showing you the super slow way to do it. So when you find out the fast way, you won't do it this way. All right. Click here, click here. This is super slow. Oh my gosh. Sorry, guys. Almost there. A few more. Oh, a couple more rows. Boom. 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 So, how's it going? Take it forever. All right. A few more. One more row. Yeah, again, I would definitely recommend this mouse. The 3D connection mouse. The space mouse, I should say. Sorry. It is super cool. All right, cool. So I selected all of them. Okay. Now I'm going to go to not tool orientation. Where was that? Sorry, I'm brain farting right now. Tool, tangents. What was it? Oh crap. Tool orientation, maybe? No. Well, let's see what that does actually. I'm gonna click OK. And let's go ahead and, well, that's not too bad. I mean, it gets it pretty close to where I want it to be. So let's go ahead and simulate. So next I've got to pick how deep I want this cutter to go. So I'm gonna close that out. Edit this. All right, so I got my speeds and feeds set up. I got my features set. Okay, now let's go to our heights and let's go to the bottom. So this is the bottom of the hole. I'm gonna say selection, and I'm going to go ahead and click on just one of these bottoms, and that's gonna bring it, that is how deep the bottom of this cut is gonna go, okay? Just on the bottom of this hole right here, since it's a counter bore, that's as deep as I need it to go. And let's bring up the feed rate just a little bit, just in case I have clamps or something there. You know, if I decide to you know, put something that sticks up, I don't want to run into it. Okay, that's something you got to think about too. All right, cool. Next, and I don't want this to be a 4-hour video either. So tolerance, I'm just going to drop it down to 1/10 of a thousandth, which is 0.0001. All right, compensation, left side, computer, good. Okay, I don't need a lead in or lead out, which is right here. I don't want to lead in, lead out. I don't need that. It's not super precise, but if I wanted to, I could. So now feed rate is going to be 10. Finishing, there's not going to be a finishing pass. It's just going to one and done all of those. All right, so here it is. Preserve order, do both ways, right? I don't necessarily want to preserve order, so whatever it does, that's fine. I don't need a roughing pass. I don't need multiple passes. It's only going down like 40 thousandths of an inch. So one cut is fine. All it is just a clearance for an insert that's going to go in here. All right. Feed optimization, don't worry. Smoothing, stock leave. I don't need stock leave, right? It's just keep this unchecked right here. All right, cool. So now I'm going to preserve rapid movement, which means that it allows it to rapid to the other position. Don't need to keep tool down. It's going to retract up to my retract height instead of keeping it down lower to the part. Okay, lead in, lead out. Don't worry about that. Okay, cool. Let's see what this looks like. So if you notice, I'm going to zoom in here. This toolpath actually went down to the bottom of this hole right here, or this counterbore, and it did its cut, which is the blue line. Okay, the blue line is the actual toolpath, and then it shows a retract, and then moves to the next one. Let's do a simulate. So I'm going to simulate that, and it's going to start in the middle there. Play. It's going to go down, and I'm going to stop it. I'm going to pause right here, just to show you. It just went down to the bottom of our counterbore right there. Okay, so that looks good to me. I have no issues with that. And I'm looking at the side to see like where it retracts, where it, doesn't, just to make sure it doesn't crash into anything. Also, sometimes you'll get a red warning when it runs into the part or something. This one we didn't, thank God. So, all right, now let's go ahead and see a simulation of this. So I left the stock on. Let me rewind it, and you'll be able to see what it's cutting. So cuts down. You can see it's just cutting around outside of the material, and it shows an example of what it's going to look like, and that looks fine to me. Perfect. Okay, cool. All right, so the next step and the last step is we need to cut a perimeter cut. Okay, we're going to do a contour cut on the outside. So again, highlight the setup one, right click, new operation. We could do another 2D milling contour. So 2D contour. Now we're going to use the same cutter, okay, which is the 1/4 inch flat end mill, which is actually a diamond shape for composites and carbon fibers and all that stuff. Okay. All right. So the coolant's disabled. All of the settings for that tool that I just made are already there. It just duplicated it. Okay. So we just move on to the next step, which is select our contour, which is going to be the outside perimeter here. So I'm just going to hover over it, and you see it highlight. Left click, and our arrow came up again. Okay. So it's outside the part where the tool is going to be, and the direction is going up this way, right? So it's going to go up, to the right, down, left, and it's going to finish it. Okay. But I need to cut more than one cut. Okay. I need to change my depth to bottom of the stock bottom. And I'm going to take, again, minus 0.150. So I'm going to bring the cutter down 150 below the part, so I don't have any issues with it not going deep enough. Okay. Stock top is already set there. You can see it's a stock top 0. Feed rate's fine. What I want to do is actually take off the tolerance to 1/10 of a thousandth, and I need multiple depths. Okay, so I'm going to click here, and I'm going to drop it down 0.1, just 100,000th depth. Okay, and it's going to take a few passes, which is fine. It's a 1 inch thick of material, and I don't want to burn my cutter, and I don't want to mess this thing up, so that works for me. Don't need to stock leave. That's fine. But what I want to do is actually go back here and add some tabs, because when I cut this thing out, it's going to be free at the very last cut, and I don't want it to mess up at the very end. Okay. So I'm going to use a triangular cut. All right. If you know, these are tabs. It's kind of telling you, it's an example of what the tabs are. Okay. The width of the tab, I'm going to say 0.25. Let's go 0.75 because it's a relatively big part. So 0.75, and the height of it, Let's go 0.75, see what that looks like. That's pretty high. I don't need the tab that big. Let's go 0.1. And it needs to be above the bottom of this part because I don't want it to separate. So 0.2, 5, oops, 0.25. Yeah, that works for me. All right. So by distance, nope. All right, so this this is how far I want the tabs to be, right? How far apart I want the tabs to be. I only need a couple tabs. So I need like, one on each side. Okay, so for this specific one, I'm going to go 8 inches from this tab around the corner to this tab. So it's got 4 tabs, just holding it in place. That should be sufficient for what I'm doing right here. So, all right, cool. And one of the last things, I'm going to have a lead in and lead out. Okay. Sweep angle, I'm going to make this at 30 degrees. All right. So it kind of sweeps in gently. All right. Lead out's the same. That's fine. The lead out is how far it goes. It kind of rounds out from the part of the edge of the part. All right, cool. So let's go ahead and click OK and right click. Let's go simulate. And right when I clicked OK, you can see these even tool paths. Okay, it actually shows the tool path going around my tab. And let's go ahead and click play. It's going to make the first cut around there. Zoom or go faster so it's not so fast or not so slow. I'm going to go to the front, and you can tell this is where it stopped. It's going to go to the next one down here. It's going to the next one down here. It's going to the next one down here. And it goes all the way down. It keeps going down. And you'll see that right when that tool, the holder hits it, it's going to turn red. And it's like, hey, you're hitting your part. Well, that's not a big deal. If I know that I'm going to stick the tool outside longer than how thick my material is. Okay, so keep that in mind. You got to kind of interpolate how far you keep that tool out. So anyway, that is how you program a part. All right, so if you guys have any questions or anything like that, let me know. And again, I'm sorry I can't get to anyone's questions on this live stream right now because this is my first video. I'm trying to figure things out here. Anyway, I hope you guys enjoyed it. If you have any questions, you can always leave a comment after I post this. Please like and subscribe if you like this kind of stuff. And maybe I'll do something a little less tedious, maybe a little bit more exciting. I do injection molding too, so I can make some molds in the future. And I will post those as well. So I hope you guys have a good night, and I will see you guys next time.